Okay, so for experiment one, we're going to explore mixing cold water and warm water together and try to find what the final temperature of that mixture is. So for this particular lab, what you're going to need is you're going to need your pocket lab, you're going to need some ice water, and I've let it sit for a little while just to make sure it's equilibrated. You're going to need some warm water, at least 70 degrees C. It could be a little bit warmer than that. Actually, I just took this off a little bit of a boil. If you have it that hot, do be careful with the water. But 70 to 80 degrees Celsius is ideal. And then I have my little measuring cup because we are going to want to measure this accurately. And again, I have my home-built calorimeter with my temperature probe already in it, all ready to go. So when you're ready to go, the big thing is that you're going to be measuring the temperature of this cold water, you're going to be measuring the temperature of the warm water, and then you're going to mix them together. When you do this mixing, you want to do things fairly quickly to make sure that you don't lose any heat to the surrounding environment and artificially lower the temperature before the mixture. So what I'm going to recommend is we're going to start off by measuring the temperature of our cold water. Then we're going to add our hot, warm water into the calorimeter and measure its temperature. And then we're going to measure out our cold water and put it into the calorimeter. The reason I'm doing that is that the cold water temperature will stay very, very stable as long as we see ice in the container. So if I measure it and then I do some other stuff and I come back and use it, that temperature will still be pretty much what I originally measured. Again, as long as there's ice in there, the ice will keep it at that pretty uniform temperature. So we need to make sure that our pocket lab is charged and connected. So I've already connected my pocket lab, but as we can see here, and let me turn off the video for just a second. I have an acceleration graph, which is clearly not what we want to measure. So just like we've had to do before, I need to change my type of graph. In this case, when I go to my graph function, we can turn off the acceleration, and what we're going to want is the temperature probe. So we can turn on the temperature probe, and that will be all we'll need. We can see that it's running. I'm kind of recording what my room temperature is in degrees Celsius, and so this tells me everything is working fine. So, as I said, my first step will be to measure the temperature of my cold water. I'm going to just put my probe in. I'm going to give it a little bit of a stir just to make sure that my probe is in the water and not touching the ice cube. So if you can look in here, I'm not actually in contact with the ice cube at the tip. I'm in the water itself. And we can see that I'm coming down and I'm getting a temperature. And I'm just waiting for this temperature to level off, which tells me I'm finding the right temperature. And so we can see this is clearly very nice and level. It's flattened out. And we can see down here that I have a temperature of around 3.6 degrees. You can measure it at this lower point down here. Okay, so I have a temperature of 3.6, or now it's 3.8 degrees. I'm going to record that temperature measurement in the table. While that's sitting there, I'm going to go ahead and put my warm water into my calorimeter. And again, what I'm going to do is I'm going to measure out the appropriate volume of warm water. Again, we're going to want to be on the milliliter scale. That could probably be a little hard to see with the camera, but there are 3 different scales on here. We want the one that says milliliters. It goes up to 30 milliliters. And I'm going to carefully measure out what the volume of the water is. I'm not going to be terribly careful because this is a demonstration, but I'm going to measure out the appropriate amount of warm water. And I'm going to put it into my calorimeter, make sure that you have enough warm water to do what we told you to do. I'm then going to take my temperature probe and I'm going to put it into my calorimeter. I'm going to press down my lid just to make sure that everything is nice and tight. And as you can see, the temperature is starting to come back up again. It's reaching an increasing value. And again, what we're waiting for is for this particular water to level out. I want to make sure that I'm sitting in the water. If you're not sure you're sitting in the water, you can pop the lid a little bit and check out. But you want to make sure that the probe's in the water. And again, we've reached kind of an asymptotic value here, so we're sitting around 67 degrees Celsius, which would be a perfectly good value to use. We can see that it is dropping a little bit. That's going to be natural, but we're going to get ready to go. So whenever I get this kind of value that I like, kind of in this case 66 degrees Celsius, I'm going to record that in the table below. And by the way, don't forget to record the volume of water that you put in the table below. Now, the next part is I'm going to add the cold water. And when I do that, the last thing I want to do is make sure that I record my temperature of my warm water right before I add my cold water. So I'm going to measure out whatever the appropriate volume, and again, it might take 2 or 3 containers worth. I'm going to carefully measure out this cold water, making sure that I don't get any ice in it. And then, right before I'm ready to add the cold water, I want to switch on the record feature, because we're going to want to record this data so that you can save it when you're done, so your professor can look at your data. So I'm going to hit record, and I can always tell when I'm recording when the data turns into these dots as a function of time. Now I'm ready to start adding the appropriate amount of cold water. So I can add a little cold water. I'm going to put the lid on if I need to add a little bit more. Okay, and again, you're going to add the volumes that we tell you to add. And when I'm done adding my cold water, again, making sure I don't get any ice in here, I just want water, I can put it in there and I can put the lid on it, and you can see that this thing started to drop off right away as I added the cold water, and the warm and the cold water began to mix. I can give this a little bit of a shake to make sure that the two of them are mixing pretty well. Don't get too aggressive. You don't want it flying out or anything like that. And again, I'm waiting for this to kind of reach out and flatten the bottom out, and that will be the final temperature of both my cold and warm water. And when I kind of reach the point where I've flattened out, I will hit stop, and I'll see kind of a nice graph. So here is when the warm water, I started to add the cold water. Here's where I actually added the second amount of cold water. And then the whole thing flattened out to give me my final temperature of the mixture. So the nice thing is that off this graph you can record at least 2 of the data points you need. One, the temperature of the warm water before you mixed it, and down here the temperature of the water after the two have been mixed together. And again, don't forget to record the masses of the warm water, the masses of the cold water that you put in, the volumes of the cold, warm water. You will calculate the masses of those, and if you're not sure how to do that, the data analysis video will walk you through that. We tell you the specific heat capacity of water, and your goal will be to then calculate what the temperature of the mixture should be and compare it to the temperature of the mixture that you actually measure. So that's experiment 1. In experiment 2, you're going to do something rather similar, except instead of adding cold water to the warm water, you're going to add cold washers to the warm water so that you can determine the specific heat capacity of those metal washers. And we'll walk you through that in another video, but the process you develop here is roughly the same. If anything goes wrong, it's a piece of cake. Just dump your water out. Of course, if you don't get good data, if you forgot to record or anything like that, you're fine. You can redo the experiment pretty easily. Just take your calorimeter, dump the water out, take a towel, paper towel or a towel, and dry it out to make sure there's no residual water. Reset your cold and warm water and just do it again. As you can see, this just takes a couple minutes to do. And when you're done with this, again, please don't forget to save your graph when you're done so that your professor can see your data.